Welcome back, class, to section 11.2, complex numbers. So a complex number is a combination of a real number and an imaginary number. Let's look at explain 1. Identify the real and imaginary parts of the given number. Then tell which of the following sets the number belongs to: real numbers, imaginary numbers, and complex numbers. Part A. So in part A, we have 9 plus 5i. The real number would be the 9, and the imaginary number is the 5i. Now together, they are complex numbers. Part B, we have negative 7i, which is an imaginary number. We can also add 0 to negative 7i to make it a complex number. So 0 is a real number, and combined they are complex numbers. Now let's learn how to add or subtract complex numbers. Adding and subtracting complex numbers is similar to just combining like terms. So to determine which operation to use, we need to look at the symbol between the two parentheses. And if we look at part A, notice how we have a plus sign, which means that we are going to be adding the two binomials. So let's go ahead and drop the parentheses. We have negative 7 plus 2i plus 5 minus 11i. Let's add our real numbers. We have negative 7 plus 5, which is negative 2. Now let's add our imaginary numbers, and that's 2i minus 11i, which is negative 9i. So our answer is negative 2 minus 9i. Now let's move on to part B. Look at the sign in the middle. The sign in the middle is a minus sign. We need to take the negative and distribute it to the second binomial. So that's 18 plus 27i, and the negative times 2 is negative 2. The negative times 3i is negative 3i. Now let's combine like terms. Combine the real numbers. We have 18 minus 2, which is 16. And combine the imaginary numbers. 27i minus 3i is 24i. So 16 plus 24i is our solution. Just a reminder that I is equal to the square root of negative 1, and I squared is equivalent to negative 1. Now let's look at something a little more complicated. Now we want to multiply complex numbers. So in my previous lessons, I've taught you how to use the box method. In this problem, we're going to be using the box method again. In part A, we have 4 plus 9i times 6 minus 2i. Since we're multiplying a binomial to a binomial, let's go ahead and draw a box that has 2 columns and 2 rows. At the top, let's write 4 and 9i, and on the left side, we're going to write 6 and negative 2i. Now let's fill in the box. 6 times 4 is 24. 6 times 9i is 54i. Negative 2i times 4 is negative 8i. And negative 2i times 9i is negative 18i squared. Class, now let's combine like terms. We have 24 plus 54i minus 8i minus 18i squared. So that's 24. 54i minus 8i is 46i minus 18i squared. So that's 24 plus 46i. Don't make the mistake of combining 46i with negative 18i squared because they're not like terms. Speaking of I squared, we know that I squared is equivalent to negative 1. So let's go ahead and replace I squared with negative 1. So now we have negative 18 times negative 1. Let's keep going. 24 plus 46i, and negative 18 times negative 1 is positive 18. 24 plus 18 is 42, and we have 46i. That said, our solution is 42 plus 46i. Now let's look at part B. We have negative 3 plus 12i times 7 plus 4i. So we're multiplying a binomial to another binomial, which means that our box is going to have 2 columns and 2 rows. At the top of our box, let's write negative 3 and 12i. On the left side of our box, let's write 7 and 4i. Now let's fill it in. 7 times negative 3 is negative 21. 7 times 12i is 84i. 4i times negative 3 is negative 12i. And 4i times 12i is 48i squared. Now let's combine like terms. This is equal to negative 21 minus 12i plus 84i plus 48i squared. We have negative 21. Negative 12i plus 84i is 72i plus 48i squared. Now let's go ahead and replace the I squared. So that's negative 21 plus 72i plus 48 times negative 1. Remember, I squared is equal to negative 1. Let's keep going. So that's negative 21 plus 72i. 48 times negative 1 is negative 48. And then from there, let's combine our real numbers. We have negative 21 minus 48, which is negative 69, plus 72i. So the answer to this problem is negative 69 plus 72i.